In this video, we are going to review how we find zeros using factoring techniques. We've had a lot of different types of factoring techniques. I've put a chart here that kind of outlines all the different types of factoring we've looked at. A couple things to remember. You must always look for a GCF first. If there is a common factor to all of them, you should factor that out first. Then we're going to use factoring techniques to break our polynomial down as far as possible. If the factor is quadratic and can't be factored any further, we can always use that quadratic formula to find our zeros, or even sometimes just square rooting to find the zeros that way. So the different types of factoring that we've looked at. Our first one, like I said, was to factor out a GCF. That's always the first piece. So we are looking for that common factor that we can divide out of each term. The second type was factoring quadratic trinomials. This is a basic process where we unfoil it. We basically are working backwards. We can always check it by foiling. We look at the 6x squared and look at ways we can break that apart, in this case the 3x and 2x. We look at factors of a negative 10. We have a couple options, negative 1 and 10, 1 and negative 10, negative 2 and 5, or 2 and negative 5. And then we basically do trial and error. We have to try foiling this back together and looking at insides and outsides to determine which one will get us the 11x in the middle. Our next type, we had a couple different special patterns. We had perfect square trinomials where we factor it and we get two identical factors. And we had difference of squares where we get one factor that has a positive sign in the middle and one that has a negative sign in the middle. And then the last two factoring techniques that we were focusing on specifically in this chapter was factor by grouping. This is the one where we have four terms, and we look for what is common in the first two terms, and then what is common in the second two terms. And then our final technique is looking at the sum or difference of cubes pattern. This is one where we end up with a binomial piece, and we also end up with this trinomial, a quadratic trinomial, and we are going to have to use the quadratic formula or maybe completing the square to find the solution for that. So we're going to look at four examples to illustrate how we use factoring to solve and find our zeros. The first one here, we do have a common factor of x, so we're going to factor that out. That leaves me with an x squared plus x minus 12. We still have it equal to 0 so that we can keep working on this solution. We now have a quadratic trinomial, and we need to look at, can we factor that further? In this case, we're looking to divide up an x squared, so we would have x times x, and we have a negative 12 as our constant. So looking at factors of negative 12, we can use a 1 and 12, 2 and 6, 3 and 4, with one of them negative. Since we are looking for a positive 1x in the middle, I'm going to use a positive 4 and a negative 3. And remember, you can always check that by foiling it back out. We then set each of our factors equal to 0. So for our first one, we've already got our solution. X could be 0. For our second one, to solve for x, we would have to subtract the 4 to the other side, and we get x equals negative 4. And for our last one, we have to add the 3 to the other side, and we have x equaling a 3. And we could always check those by plugging them back into our original equation. Our second one, we do not have it solved where we have one side equal to 0, so that would be our first step. So we have 2x to the fourth minus 26x squared minus the 28 would get us to a 0 on the other side. We then look through it and notice that there is a 2 that is a GCF of all of those. So if I factor the 2 out, I have x to the fourth minus 13x squared minus 14. Again, it's still equal to 0. We do have a trinomial that we can factor. It has a higher power here. It's an x to the fourth, but it fits kind of our quadratic pattern. So I'm going to split that into an x squared and an x squared. I'm then going to look for factors of negative 14 that would add up to negative 13. So if I use a negative 14 and a positive 1, when I do my foiling, insides and outsides will add up to that negative 13x in the middle. I then have to take each of my factors and solve for 0, or solve for x, I should say. So I'm going to look at when does x squared minus 14 give me a 0, and when does x squared plus 1 give me a 0. Notice that this 2 in front doesn't have an x, it's just a plain constant 2, so we don't have to worry about an x value there that would be a 0. I'm going to add the 14 to the other side, and then I need to square root to solve that. So I end up with x being positive and negative square root of 14. My other one, I have x squared plus 1 equals 0. If I move the 1 to the other side, now I am square rooting a negative number, which is what leads to those imaginary solutions. So I end up with x being plus or minus I. So I do have 4 solutions, 2 there and 2 there. And if we look back, highest power was a 4, so we have found all of our solutions. Example 3, notice that we have 4 terms, so we're going to use that grouping technique on this one, which means basically I just split it in half. What is common in the first 2 terms would be an x squared. It leaves me an x minus 5 left over when I divide out an x squared. And then when I look at my second half, I can take a 6 out. That is common. It does leave me an x minus 5 as well. And again, as long as the leftover part, this x minus 5, matches, that is going to be one of my factors. The other factor comes from the 2 pieces that we have pulled out. So we end up with x squared plus 6 as our second factor. Again, we could FOIL that back out to double check our work. We then need to set each of our factors equal to 0. So x squared plus 6 equals 0, or x minus 5 equals 0. X minus 5 is easy to solve. We simply add the 5 to the other side. For the other one, we are going to subtract 6 to the other side. Then we have to square root. And because it's negative, we are going to get that imaginary answer. So we have plus minus I root 6. So I have 2 solutions here. I have 1 here with the x equaling 5. And I look at my power. My highest degree there is a 3. So we have found them all. All right, our last one is x to the 4th plus 64x equals 0. I can factor an x out of all of that. I now look at the x cubed plus 64. That is a sum of cubes pattern. So I am going to break that down. We end up with a binomial and a trinomial when we factor a sum or difference of cubes. I look for the roots first. So the root of x cubed, the cube root of that would just be an x. The cube root of 64 is a positive 4. And then the trinomial piece, I take the first term x and square it. I take the product of these two, so 4x, and change its sign, so negative 4x. And then I square the second term, which gets me a 16. Setting each of these equal to 0. One of my solutions is that x could be 0. One of my solutions, x plus 4 being 0, would lead me to say x would have to be negative 4. And the trinomial piece, since it can't be factored any further, I'm going to need to use the quadratic formula for that. So I'm going to use quadratic formula. I have x equals the opposite of b, so positive 4, plus minus the square root, b squared, so negative 4 squared, minus 4 times a times c. And I'm dividing the whole thing by 2 times a. And then it's just a matter of simplifying the quadratic formula. X equals 4 plus minus the square root. Negative 4 squared would be 16. 4 times 1 times 16 is 64. I'm subtracting that all over 2a, which would be a 2. So I have 4 plus minus the square root of negative 48 divided by 2, which gets me 4 plus minus, and if I break up that 48, I'm going to have a 16 times 3, so I would have a 4 root 3. Since it's negative, I'm going to have 4i root 3. And then I can divide both of those by 2, so my final piece would be 2 plus minus 2i root 3. So I have 2 solutions there, and I had 2 other solutions here. So that accounts for all 4 of my possible solutions.